Section 4, Angles of Elevation and Depression. So just a few reference terms in this section. We have a horizontal line here and here. The angle of elevation is from this bottom horizontal line and this angle up, and the angle of depression would be from this top horizontal line and this angle down. So this first example, you can just draw a sketch of the picture. You don't have to draw the air balloon and everything else. So what is a description of the angle as it relates to the situation below? Angle 1 is this angle. We have our top horizontal line, we have a middle horizontal line, and we have a bottom horizontal line. So we have, if we're looking in this picture, this is an angle of depression, this is an angle of elevation. If we're looking in this picture, this is an angle of depression, and this is an angle of elevation. So angle 1 is the angle of depression from the bird to the person in the hot air balloon, whereas angle 4 is the angle of elevation from the base of the mountain to the person in the hot air balloon. So there's two situations here. There's two angle of depressions and two angles of elevation. So a few uses that you would have for this. So you sight a rock climber on a cliff at a 32-degree angle. So this is our 32-degree angle. Your eye level is 6 feet above the ground, and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So we're looking for this measure. So we're looking for the side opposite the angle of 32 degrees, and we have the adjacent as well. Opposite and adjacent is using tangent. So the tangent of 32 degrees, and that's going to equal the opposite over the adjacent. So to get x by itself, we would multiply both sides by 1,000. Now we get the tangent of 32 degrees times 1,000 is going to give us about 625. But you're already 6 feet above the ground, which means the approximate height of the rock climber from the ground is going to be that 625 plus that extra 6 feet, which is going to give you about 631 feet. And that's how high the rock climber is from the ground. Now this next example, to approach a runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3 degrees descent, starting from a height of 2,714 feet above sea level. The airport itself is about 107 feet above sea level, which means we're talking that this airplane is 2,714 feet above sea level, but the airport is 1,007 feet above sea level. So that leaves me with 1,707 feet for this distance from the airport from the ground of the airport to the plane that's in the air. To the nearest tenth, they're looking, of a mile, how far from the runway is the airplane at the start of this approach? So we're looking for the hypotenuse. So if this is 3 degrees, then this is 3 degrees, because these lines are parallel and these are alternate interior angles. So that's how we get the angle that's inside of the triangle that we're looking at. Then we have the opposite, and we're looking for the hypotenuse. Well, which one uses the opposite and the hypotenuse? Sine. So we're going to do sine of 3 degrees equals the opposite, 1,707, over the hypotenuse. Now you can set this up as a proportion and cross multiply, or you can just multiply both sides by x and then divide by sine of 3 degrees. You're going to get that x equals 1,707 over sine of 3. When you do that in your calculator, you divide it by the sine of 3 degrees, and you should be getting approximately 32,616.2, let's say. But the important thing here is that we need to convert that number that's still in your calculator into miles, because right now it's in feet. So we know that there are 5,280 feet in 1 mile. So feet in 1 mile, 5,280 feet in 1 mile. So we're going to take this number that's still in your calculator and divide it by 5,280. And we get to the nearest tenth of a mile that it's approximately 6.2 miles away.